पुराने जमाने के
टीचिंग के तरीकों से
हमको क्यों पढ़ाते हैं? इट्स सो बोरिंग।
अब वेदांतु देगा प्रॉब्लम से छुटकारा।
हाय किड्स,
समझ
हेलो टीचर।
आएगा तो मजा आएगा, मजा आएगा तो समझ आएगा।
बेस्ट टीचर्स पढ़ाए तो सिंपल लगे एवरीथिंग।
लीडरबोर्ड्स एंड क्विज़ेस से
Amazing.
learning हो जाए हैपनिंग। समझ आएगा तो मजा आएगा, मजा आएगा तो
Vedantu. Learn live online. To attend a free live class, download the app now.
Hey guys, welcome back. This is me, your Suri Sir, and you are watching me on Vedantu's JEE channel. And I'm back with another interesting session of Killer 5. Well guys, in today's session, we are going to tackle the problems from Mechanics 2. Now what exactly Mechanics 2 contains of? It basically starts from rotation motion and goes till the waves motion. Okay guys, so let's start with our Killer 5 series, and here is the very first question for all of you. Well guys, let me tell you what exactly this question is all about. This question tells us that there is this arrangement. This arrangement has a rod of length L which is pivoted at this end, and on the other end of the rod you have a disc whose mass is given, whose radius is very small in comparison to the length of this rod. Now, question wants us to consider two cases. Case 1, when the rod cannot freely rotate about the hinging point, and in case 2, it's free to rotate. Okay, so case 1, no rotation of the disc. Case 2, rotation of the disc. Now, question tells us that if we take this arrangement to a certain height and release it from there, then what will happen? Yes, oscillations will start. So question wants us to find out that if those oscillations are going to happen for case A and case B both, then which of these four statements are going to be true? Possibilities of multiple correct statement, a question from JEE 2011, when multiple options could be correct. Okay guys, so the first statement says that the restoring torque which is there in case A is equal to the restoring torque of case B. Statement 2 says restoring torque in case A is less than the restoring torque of case B. Option C says that angular frequency of case A is greater than that of the case B, and last option says that the angular frequency of case A will be less than the angular frequency of case B. Okay guys, now in the very first read, sometimes it's very difficult to gauge what exactly is to be done in the question. Well, I'll tell you how exactly to approach this question. Well, when the dynamics becomes relatively challenging to approach, you should always approach the question first from the work, energy and power understanding. Okay, I told you that work, energy, power is a very fundamental chapter, just like laws of motion. Its concepts will be applicable throughout your studies of physics, not only just till 12th standard. Maybe when you are pursuing your engineering, you will see that these laws which you study, they are laws of motion and law of conservation of energy. Also, the law of conservation of momentum sometimes are very crucially applicable in many of the cases when you're dealing with questions which are related to mechanics. Okay guys, so let's go ahead and find out the solutions to this question. Cool guys, so now what has been given in the question, that say initially the disc was somewhere here along with the rod, and now what you have done, you have taken the disc along with the rod to a certain height h. Okay, so say that if we are talking about the two cases, I'm going to say that for case A, if we say that the potential energy when the body was released from this height h for case A and case B, can I say that the potential energy is going to be same for case A and case B, and that is basically the total energy that is possessed by the system? Which means what? If we write the total energy of the system, we can say that when the system is at the maximum height here, when the system will also stop during the oscillation, it will have some potential energy in case A. Okay, and when it will be moving and will be say reaching the bottommost position where the entire energy becomes kinetic, then the kinetic energy of A, and this is going to be because of translation only. That means what? Let's just say that it is going to be kinetic energy at A, and when we'll be writing, let's not just call it translational, it is rotation energy. So I'm as of now just writing it as kinetic energy of A. Okay, when we speak about case B, the potential energy of case B will eventually convert into kinetic energy of B at this position. This is where the potential energy will be the only form of energy, because the body will be starting from there, and when it will be reaching here, it will be having some kinetic energy and no potential energy. Now what we know is that these values are equal. That means the point where you started from, the two systems, the two cases had the same amount of potential energy. Okay, I think that there should not be any doubt there, because we are taking the entire system there, and from there we are releasing it everything from the rest. That means initially the potential energy that we gave it to the system, it is equal. Now the system, when it is reaching here, that is where the differences start coming into picture. So when I write it for case A, in case A, the rod is going to rotate along that line, or you can say the oscillation path, but the disc will not be able to rotate along the point of hinging. That means what? No rotation of disc will be considered. All we can say that this energy will be equal to the kinetic energy of A will be equal to the kinetic energy of case B. But when I'm writing the kinetic energy of case A, I will write it as half m plus capital M times V. In fact, let's just write it as the total mass m. So if I write it as half, let's say that it is total mass capital M dash, and the velocity at A, this is VA square. Okay guys, when we will be writing the kinetic energy at B, this time obviously you will write some translational kinetic energy, that is half M VB square. This is B is representing case B here. Okay, but along with this, your disk has also started rotating. That means what? There will be some rotational kinetic energy of that disk, which is half I omega square. Okay, which means what, guys? In this case, if we write it as say omega B, okay, now what you see here, that this kinetic energy has to be equal to this plus this kinetic energy. Means what? Can I say that if we just compare the translational kinetic energies, then this half mVA square should be greater than half mVB square, which concludes us to say that VA should be greater than VB. Yes or no? So the linear velocities at the bottommost point will be greater for the case A than that of B. Now if I consider the angular frequency about this point of hinging, we know that V will be equal to omega R. R will be same for both the cases with respect to their center of mass, you can also say. So can I conclude that the angular frequency of A will be greater than the angular frequency of B? Okay guys, this omega and this omega are different. This is angular velocity of the rod about the hinging point, which is here. Let's call it omega dash. Okay, so now there is no confusion. In case A, the angular velocity will be more in comparison to that with case B. That means what? We can say that the case C, option C, is surely correct. Okay guys, now apart from this, when we speak about the torque, because of checking option A, because first two options are about the torque, can I say that if we consider the center of mass of the rod, which is here, this is how the weight will be acting, and for the disc, capital mg will be acting from here. And when we are starting from this point, both the situations seem to have the similar situation of the gravity acting on the rod as well as on the disc. Which means what? If you will try to calculate the torque, you will be calculating the torque for both case A and case B, and you will be writing it as this force, that is mg, which is, say this angle is theta, so the angle between R and mg will be theta. So this is mg acting at a distance L by 2 multiplied by sine theta, that's the torque on the rod. And along with this, you will write the torque of the disc, which is capital mg acting at a distance L into sine theta. Which means what, guys? The torque will come out to be same for both of them. There will be no difference in that, because the gravity and the weight, which is responsible for the torque application on both the rod as well as on the disc, is coming out to be same. That means what, guys? What we conclude here? We conclude that first option is correct, that is option A. So this option is correct. Restoring torque in case A is equal to restoring torque in case B, and moreover, angular frequency of case A is greater than the angular frequency of case B. Okay guys, that's a question from JEE 2011, and that was our very first question in the Killer 5 series. let's go ahead and go for the next question. Okay guys, cool. So let's see this one. Now read this one. Now this question says that you have a wire, thin wire of length capital L, whose linear mass density is uniform, and the linear mass density is given as rho, and is bent into a circular loop with center at O. So you can see that the diagram is here. This was basically the wire, you can say that, or in fact that is not the wire, that is considered to be an axis of rotation. Say that's the kind of wire we had, whose mass is not given to us, but linear mass density is given, length is given, so we can find out the value of the mass as well. And now it has been converted into the loop whose center is at O, radius has also not been given. What we have to find out is the moment of inertia of this loop which has been formed, that means a ring, and the axis of rotation is one of the tangents. Okay guys, so now if you think about the question, let's just forget about the wire for a moment. Let's just think about the ring first. So when we are talking about the ring in general, okay, so in ring, if we know the mass and the radius of the body, an axis that is passing through the center and perpendicular to it, that means this is the kind of rotation that happens. We know that the moment of inertia in that case comes out to be mr square for the ring. Okay, now if the axis of rotation changes, you make one of the diameters to be the line about which the axis of rotation is passing by. That means this is the kind of rotation that is happening. Then in that case, say that one, first one was I1, this is I2. Now the moment of inertia comes out to be half mr square. You can find that out by using perpendicular axis theorem as well. Okay, theorem of perpendicular axis can be used, because if we consider an axis like this, then also the moment of inertia will be same. So I plus I will be equal to Iz, which is mr square. So 2I will be equal to mr square, and I comes out to be half mr square. So far so good. So this is what is going to be the moment of inertia about the axis which is passing through the diameter. That means what? If we draw a line here, then this is the moment of inertia which we are calling as I2. But question wants us to find out the moment of inertia about this axis, and this is the moment of inertia which is unknown. And in this case, the axis of rotation has been shifted by a distance that is equal to the radius of this thing. That means what? Can I say that I2, rather I, which is unknown, will be equal to I2 plus md square, which we know as the theorem of parallel axis. Okay guys, so we'll be going after the question to find out the value of I2, mass of the body, and this distance is already known. So let's try to find out the mass of the ring. Let's try to find out the radius of the ring, and after that the question will be very easy to tackle. Okay, so by parts, I think the question is clear. Let's go ahead and try to solve this one. Okay, cool guys. So using a separate sheet for this thing, we have to find out the moment of inertia about this axis of rotation. We called this as, say, I dash. Let's call this as I, and this distance is R. We are clear that we are going to find out the value of I, which is equal to I dash plus mr square, because the value of D is R, and I dash value will be half mr square plus mr square. That means what? The value will be 3 by 2 mr square. So this is what we are going to solve for. So now what do I need in this question is only the value of mass of this ring which is there, and the radius as well. Okay, so guys, what is given to us is that the wire which is there has a uniform linear mass density, that is rho, and has a length L also. Let's see this. Yes, the length is given as L, and the mass has also been given as the mass density is given as rho. Fine. So we can say that linear mass density is mass upon length. So mass becomes density times the length. So easily found this value. Next thing that we need to find out is the radius. So we can say that the length of the wire has become the circumference of this ring. So 2 pi r is equal to the length of this wire, which means what? The radius of the ring becomes L upon 2 pi. Okay. So we have got the two unknowns for putting it in the question here in the equation of the final moment of inertia. So let's go. So the moment of inertia I will be equal to 3 by 2. The mass is equal to rho L, and the radius square will become L square by 4 pi square. Okay guys, that means the moment of inertia finally looks like 3 by 8 pi square times rho L cube. So this is somehow the answer should look like 3 rho L cube by 8 pi square. Let's see the options here. So 3 rho L cube by 8 pi square, that means answer is option D for all of us. Okay guys, so turned out to be a question which was supposed to be broken down into parts and tackle each part individually first, get the value of the moment of inertia of the ring, and before that we should know the values of moment of inertia of the ring for all the possible axes for which generally we know the axis of rotation passing through the center of mass. Okay guys, so this was our question number 2. Let's move on to the next question here, and this is the next question, and the question is from gravitation from JEE 1995, that too for the subjective part of the paper. Cool guys, so the question says that there are two stars. One is of mass 16 m, radius 2a, another is the smaller star having mass m and radius a. They both are separated by a distance 10a. Okay, so the separation between them is given as 10a to us. Their centers are separated by this, and now what we are doing, we are launching a body from here whose mass is small m. So from the bigger star we are going to launch a body of mass m, and question wants us to calculate the minimum velocity that you should give this body at the surface of the bigger star so that it successfully reaches the surface of the smaller star. Okay, we have to find our expression in terms of capital G, capital M and A. Is the question clear? We have to send this body of mass small m from the gravitational field of this bigger star to the gravitational field of the smaller star. Now, I know that in the very first appearance, this question seems to be very easily doable. I'm not saying it is very challenging, but it is at a point tricky. Why it is tricky? Because if you will consider the question to be solved by considering the law of conservation of energy, you will just directly write down the initial energy of this mass along with the star 1, or you can say star 2 S2, and then you will try to equate it with the energy of the mass along with the star S1. Then in that case, you will be eventually making a mistake here guys. Reason being, you will be forgetting the point that when the mass is starting from the surface of bigger star and finally coming to the surface of the smaller star, till a point in between, let's call this point as P, it is under the influence of the gravitational field of star S2. Means beyond point P to the right side, the gravitational field of star S2 is more strong. And when you cross that point P towards star S1, then the gravitational field of star S1 starts coming into picture. Means what? To make this body reach this star, you don't have to send the star to this surface, you just have to send it to this point P where the net gravitational field because of both the stars is 0. Because if you make the point body cross this point, if you make this body point m mass, small m mass, cross this point P, after that you don't have to have any velocity to be given. Means what? Even if it reaches with 0 velocity to point P, after that it will be pulled by the gravitational field of this star, because that is the zone where its gravitational field is stronger. Okay guys, I hope that the question is clear. So we have to basically find out first that point P where the net gravitational field has to become 0. After that, what we'll do, we'll try to write down the value of the gravitational potential at that point P, and from this point to this point, or rather just the potential energy, we'll basically try to send the body from this point to this point. That's it. Beyond that, the body will be taken care of by star 1. Okay guys, so let's go ahead and try to solve this question. Okay, so what has been given to us is the separation between the two stars, that is 10a. A body of mass small m will be launched from here. Let's consider a point P where the net gravitational field G effective will become 0. So let's calculate that first. So for gravitational field to be 0, let me do this calculation here itself. We'll be writing it as G capital M by, say, this distance is x. So obviously the remaining distance from here becomes 10 minus x. Okay, so Gm by x square should be equal to G 16m, that's the mass of the second star, divided by 10 minus x the square. So gm gets cancelled, taking things on the other side. So 10 minus x square is equal to 16x square. Okay, you can see that simple square root. So 10 minus x is equal to 4x. What we get is 5x equal to 10. So x comes out to be 2. Or if we say that the entire gap is 10a, so this will come out to be 2a. Okay. Okay guys, that means we have this gap now. This gap is 2a and this gap is 10 minus 2a, which is equal to 8a. So we know the point from the bigger star, how far you have to bring the body of mass m from a distance from the center, from that is 2a. So from center of star 2, that is O2, its separation initially is 2a. You have to make that separation increase to 8a. That's all you have to do. Okay, now what I'll do, I'll be basically conserving the energy now. So when I say that energy at O2, or say, let's say the surface of S2, so energy at the surface of S2 should be equal to energy when the body has reached point P. So when you are writing the value of the energy of the body at the surface of that star, say it has got some velocity, so it has the kinetic energy, that is half mv square. And now you will be writing the potential energy. So when you are writing the potential energy, guys, we know that potential energy term is minus gm1 m2 by r. You will not only write its potential energy with the star S2, it is also going to store some potential energy with star S1. Okay guys, so we'll be writing both the terms here. So minus of g16m small m, and this small m divided by the distance between the star and the body, that is 2a, and minus of g, this is capital M. The separation here, if you look at it, this is total gap 10, separate 2a from that, so that is 8a. So gm small m by 8a is the initial energy of this system. Not writing the energy that is stored between O1 and O2, or you can say S1 and S2, reason being they are not moving, so their potential energy is not changing at all. And this should be equal to the energy at point P. So at P, say the kinetic energy becomes 0. Means the body, when it is reaching there, it is not even having any velocity. After that, it will be taken care of. And if we write the value of the kinetic energy which came out to be 0, let's write down the potential energy now. So it has G16 m small m, and the gap is how much from the center? It is 8a minus g capital M small m by the gap, that is 2a. Okay guys, let's try to simplify this now to get the value of v. This is what we needed. So what we get from here is half mv square minus, if we simplify this, this will be, to make it 8, multiply this by 4, so this will be 64g capital M small m by 8a, adding 1 from there, this value becomes 65g mm by 8a, and this is equal to the right side, again multiplying this by 4, dividing it by 4, so you have 16 minus 4 becoming minus 20g mm by 8a. Okay, now what you do, you bring it this side, so you get half mv square is equal to 65 minus 20, that is 45 g capital M small m by 8a. That is the expression of kinetic energy when the body has to start from the surface of star 2. So now what you can do, you can cancel this small m, you can cancel this 2 with this thing, this is 4. So v square is coming out to be under root of 45g m by 4a, and 45 can be written as 9 into 5, so 3 can be taken out, so we have 3 for this 4, 2 will come out, and you will be left with under root 5, so 5g capital M by a. Okay guys, so this is what the final velocity, in fact as of now this is looking like a square or equal to square value. Let's just write it separately somewhere here. Okay, so the final velocity will become 3 by 2 under root of 5 gm by a. You can try to take this 3 and 2 inside, so it will become 9 multiplied by 5, so that will be 45. 2 goes inside, becomes 4. So that's why the final minimum velocity that is required by the body to start from that star comes out to be 3 by 2 under root 5 gm by a. Okay guys, I hope that you liked the question, reason being the point P, a very crucial point, because without that consideration, if you directly equate the energy on the surface of star 2 and surface of star 1, then what you are actually considering is the additional kinetic energy that you are giving for the part P2O1. That energy is not required. Your answer actually will come out to be more velocity required at point, which is surface of the star S2. Okay guys, cool. So this is another question that we saw. I think this was the third question. Let's move on to the next one. Well, let's have a look at this question, guys. Have a look at this. This question is from SHM. This says that the period of oscillation of a simple pendulum of length L suspended from a roof of a vehicle which is moving without friction down an inclined plane of inclination alpha will be given by what? So we have a vehicle on which a simple pendulum is hanging, and that vehicle is coming down with an acceleration which is not given, but we know that that value is g sine theta, or in case this g sine alpha is the acceleration with which your vehicle is coming down. So because of that, what will happen to the pendulum? You have to find out the new value of the time period of the oscillation of that thing. Means what? All you have to do is basically find out the value of time period, which is given by 2 pi under root of L by G effective. This is what you have to solve, guys. 2 pi under root of L by G effective. So let's try to find out the G effective value here. So what is happening here is that inside this vehicle, your pendulum basically goes in this position, okay, such that it is experiencing a force that is mg on the inclined plane, and along this line, if you try to resolve this, you know that this force will be mg and this force is going to be mg sine theta, in fact mg sine alpha. This is mg cos alpha. Okay, so if we look at it from the point of view of, say, the pseudo force, so we know that the pseudo force will be acting in the opposite direction. So what will happen here, the two forces that will be acting on the body, let me just try to tell you the question from the non-inertial frame of perspective. So in this situation, what will happen, that your pendulum bob will be experiencing a mg downward and will also be experiencing a mg sine alpha as the pseudo force, such that we know that this angle is going to be alpha here. Okay, so if we just look at the value of the accelerations here, because we have to find out the value of G effective, so we can say that this is G and that is G sine alpha. Okay, all we have to do is find out the net resultant of these two. This is what we are calling as G effective vector. The angle between these two becomes 90 plus alpha. So in order to solve that, all you have to do is apply the parallelogram law of vector addition, find out the value of G alpha, you'll be able to get that value. So guys, G effective square will be equal to G square, that is A square, plus G square sine square alpha, plus this is A square plus B square plus 2AB cos theta. So 2A, this is B, and cos theta, which is 90 plus alpha in this case. This is G square. Okay guys, that means what you get here is G square plus, I can take G square common out of the bracket, so I have 1 plus sine square alpha plus this G square taken out, 2 sine alpha, and cos 90 plus alpha is minus sine alpha, so putting up a minus sign here, and sine alpha will multiply to give you 2 sine square alpha here, guys. That means what? 1 plus sine square alpha minus 2 sine square alpha will give you 1 minus sine square alpha. That means you have g square 1 minus sine square alpha. This is your g effective square value, and 1 minus sine square alpha, as you all know, is cos square alpha. So this is g effective square. That means what, guys? The value of g effective comes out to be g cos alpha. As simple as this. That means instead of writing g effective now, you can write down the final value of expression as 2 pi under root of L by g cos alpha, and that will be the answer to this question. Okay, that is option A. So what happened here in the question? Because of the acceleration of the system, the body which is oscillating, which is pendulum, also start experiencing a pseudo force, and with that pseudo force, what happens here, we basically consider a pseudo force along the direction that is opposite to the direction of acceleration, because in this time the body is accelerating, so that's why the body will experience a pseudo force. Because of that, a pseudo acceleration g sine alpha comes. This is g, which is the weight of the body. We found the resultant of these two, which is what going to give us the net effective acceleration under gravity experienced by the body. So we get the answer as 2 pi under root L by g cos alpha. Okay, guys, so this was JEE 2002 question. Let's go ahead and solve the next one. The next one and the fifth one is a question from Dopplers Effect. Well, guys, what does this say? That we have a police car with siren of frequency 8 kilohertz, which is moving with uniform velocity 36 km per hour, which is basically 10 meters per second, towards a tall building which reflects the sound wave. The speed of sound in air is given as 320 meters per second, and the frequency of the siren heard by the car driver is to be found. So what is so special about this question? The special part about the question is that the police car which is creating the sound, it is initially the source of the sound also, and later on will also become the observer of the sound. Why will that happen? Whenever, say, a vehicle is approaching a reflecting surface of sound, then what happens? Initially the sound which travels from this behaving as this to be the source, which is, say, frequency generated by it being n naught, the sound which goes to the wall gets reflected back. So when it is reflected back, the vehicle is still under the relative motion with the wall. So because of that, if I say that the frequency which is received at wall is n1, the frequency which will be received back by the car will no more be n0 or n1, rather that frequency will become n2 when it started with a frequency of sound of n0. How to approach this question is basically by breaking this question into two scenarios. First scenario, when your car is the source of sound, and say there is an observer who is standing or sitting on the wall. So n1 is basically the frequency that is heard of sound by this observer. For that, I hope that you know this formula, that usually the apparent frequency that we calculate, the apparent frequency is to be calculated as C plus minus VO divided by C plus minus VS times the original frequency. So I'm writing both plus and minus cases in the formula. Reason being, all you have to remember, or rather think about it, you will not need to remember this. Whenever the observer and the source come closer, whenever the relative motion is bringing them closer, the frequency of the sound which is heard apparently is more shrill, that means is higher than the actual frequency when the two are coming closer. If they are going away, if they are going apart, then in that case the frequency of the sound that is heard by the observer will be less than the original frequency. That means sound will be less shrill when they are going away from each other. So when we speak about, say, the case 1, okay, so we know the formula now. When we are speaking about case 1, let me just basically derive the situation here first, then we'll put up the value. So when we are speaking about the case when the car is source and wall is your observer, Okay, in that case, this formula says that, let's call it the frequency which is received at the wall as n1. So now what is happening? Your observer is wall and it is stationary. Your source is car which is moving. So when the car is approaching towards the wall, can I say that the relative separation between the car and the wall, which is between source and the observer, is decreasing? So frequency heard should be more. So first of all, in the numerator you will just write C because VO is 0, and in denominator you should write C plus V or C minus V. It's a call that you will be taking based upon your understanding whether frequency should increase or decrease. So basically you want to multiply N0 with something which will make N1 greater than N0, because frequency heard will be more than N0. So that will only be possible when you divide C by a number which is smaller than that. That means C minus Vs. And what is Vs? Let's call it the police car Vp. Okay guys, you can see that this ratio will give you a value which is greater than 1. That greater than value 1 multiplies by greater than 1 value multiplies with N0 gives you a value N1 greater than N0. That's case 1. Okay, now when your car is observer and your wall has become the source. How it has become the source? It is reflecting the sound back to the car. So in this case, now the frequency heard by the car observer will be N2. And now observer is moving and the source is stationary. That means denominator is surely C. Because now what is happening in the formula? Source is not moving. Source has become wall. And you have to have your initial velocity, initial frequency, which is starting from here as N1. Not N0, but N1. Okay. Why am I writing it as N1? Is because now the sound which is starting from the wall to the police car is having a frequency N1, because that was the frequency which was received by the wall. And we know that when the wall is stationary and still the car is approaching the wall, again the relative separation between the two is decreasing. That means N2 should be greater than N1, and that is very easy to predict. The numerator has to be greater than the denominator. That will be the case when you add C with the speed of the observer, which is police car. Getting it? C plus V by C, this ratio will be more than 1 multiplies with N1 give you N2 greater than N1. And now what you have to do is take this equation number 1, and this equation which you have got, which is equation number 2, and just write them together. That simply means put N1 in N2. So this equation you will be putting up here, and you will be finding out the final formula here. So when you will be doing that, let's see what will happen. So when I'm doing this, I'm getting N2, which is the final frequency which is observed by somebody in the car. So I'll be writing C plus Vp divided by C multiplied by N1, which has become C divided by C minus Vp multiplied by N0. Okay, this is basically your N1. You can see that C getting cancelled. What you are getting is C plus Vp divided by C minus Vp multiplied by N0. So from now onwards, you can directly use this approach and use this formula also to solve this question. Okay. So now what we are left with is only the numerical values to be put here. So let's do that. We have the final formula to appear as C plus Vp divided by C minus Vp into N0. So the velocity of sound is C, that is 320 plus 36 km per hour. When you will multiply it by 5 by 18, you will get the value as 10. So this is 10, this is 320 minus 10, and the frequency which was originally produced was 8 kilohertz of frequency. Okay, that means what? You get 330 by 310, that means 33 by 31 multiplied by the value 8, very close to 1 this fraction is going to be, but very close are the other two options. So the answer finally will come out to be 8.5. Okay, so 8.5 kilohertz is the frequency that is apparently heard by people who are there in the car. Okay guys, so this was our fifth question from the Killer 5 series, and that is the last question of the series for Mechanics 2 as well. I hope that you guys liked the question that we have done today, and in general, if you are having fun with us guys, then if you have not gone to our app yet, I think now is the time for you guys to go on the Play Store, just type Vedantu, download the app, and you can get all your queries and doubts related to your academic preparation to be solved on the Vedantu app itself. Not only just that guys, sometimes what happens when we are preparing for exams like JEE and even with our board examination, there are chapters which actually bother us. We say that I'm usually good at physics, but there is a chapter, say rotation motion, which creates problem for me. I'm not able to get the gist of that chapter. I'm not able to crack questions which are very, very, very good in terms of the difficulty level. Then we have a solution for you to just focus upon a particular chapter in a given subject. What we call them are our micro courses. Well, these micro courses, as the name suggests, are basically going to take you to focus only on a given chapter. You don't have to come for the entire subject. You can come for only a single chapter, and what you get in that, you get to prepare for all the competitive examinations which are there. You can do the live learning with all of us, the master teachers at Vedantu, including me, and apart from that, you can appear for the multiple tests which are based on chapters as well, and you get unlimited doubts, which are live doubt sessions for all of you, along with the quizzes and the test. So all you have to do is either you go on the app to buy those micro courses, or you can also follow this link, and in the link, when you are going there, don't just directly click anywhere, just go for this code. SHMIC is the code that you have to fill there, and what you get is a massive discount of 95%, and that's how you can make your preparation for a given chapter in a subject relatively much more easy. Okay guys, so this was our Mechanics 2 session for Killer 5 series, and I'll be back again with another interesting session in the series of Killer 5. Till then, if you have not, then like, share, subscribe to the Vedantu's JEE channel. Okay guys, so I'll be seeing you again very soon. Bye-bye. Take care.